Hello guys, welcome to this new video about mesh analysis method. Solve the problem number 2. Given the electric circuit with R1 2 ohms, R2 3 ohms, R3 3 ohms, R4 4 ohms, R5 1 ohm, and we have three voltage sources. V1 is 1 volt, V2 is 2 volt, and V3 2 volt. The question now is to calculate the mesh currents IA, IB, and IC. Let's go to the solution. Let's start first with mesh 1. By applying Kirchhoff's voltage law in mesh 1, we can write negative V1 plus R1 IA plus R2 IA minus IB is equal to 0. By replacing the resistors and voltage with their numerical values, we obtain negative 1 plus 2IA plus 3IA minus IB is equal to 0. If we continue simplifying this equation, we obtain negative 1 plus 5IA minus 3IB is equal to 0. After we finish from mesh 1, we go to mesh 2. By applying KVL in mesh 2, we can write R2 IB minus IA plus 3IB plus R4 IB minus IC minus V2 is equal to 0. By replacing the resistors and voltage with their numerical values, we obtain 3IB minus IA plus 3IB plus 4IB minus IC minus 2 is equal to 0. If we continue simplifying this equation, we obtain finally negative 3IA plus 10IB minus 4IC minus 2 is equal to 0. We go now to mesh 3. By applying Kirchhoff's voltage law in mesh 3, we can write R4IC minus IB plus R5IC minus V3 is equal to 0. By replacing the resistors and voltages with their numerical values, we obtain 4IC minus IB plus IC minus 2 is equal to 0. If we continue simplifying this equation, we obtain finally negative 4IB plus 5IC minus 2 is equal to 0. Finally, we obtain three equations which are necessary to find IA, IB, and IC. Those three equations can be expressed using matrix form as follows, where matrix A is equal to 5 is the coefficient multiplying IA in the first equation, negative 3 is the coefficient multiplying IA in the second equation, and 0 is the coefficient of IA multiplying IA in the third equation. Negative 3 is the coefficient multiplying IB in the first equation. 10 is the coefficient multiplying IB in the second equation, and negative 4 is the coefficient multiplying IB in the third equation. 0 is the coefficient multiplying IC in the first equation. Negative 4 is the coefficient multiplying IC in the second equation, and finally 5 is the coefficient multiplying IC in the third equation. We have I is the current vector is given by IA, IB, and IC, and the vector B is given by 1, 2, and 2. Now we are going to apply Cramer method in order to solve those three equations. We start first by calculating the determinant of A. How we calculate the determinant of A? We have 5 and we cancel the first row and the first column. It rests only 10, negative 4, negative 4, 5. Then we need to calculate the determinant of 10, negative 4, negative 4, and 5. Plus, why? Plus because we have here plus, minus, plus. We have minus, minus 3, we have a 3, and we cancel the first row and the second column. We obtain determinant negative 3, negative 4, 0, and 5. and we have the third one is 0 multiplying something is always 0. Let's start with the first one. We have 10 multiplying by 5 minus negative 4 multiplying negative 4 multiplied by 5, we obtain 170. And the second one, negative 3 multiplying by 5 minus 0 multiplying negative 4 multiplying all by 3, we have negative 45. We obtain finally determinant of A is 125. We define now matrix A1 by this matrix. We obtained A1 by replacing the first vector of A by the vector B. So we go now to calculate the determinant of A1. We start first by 1 multiplying by, when we cancel the first row and the first column, we stay only 10, negative 4, 5, negative 3, minus negative 3, and we cancel the first row and the second column, it stay only 2, negative 4, 5. So determinant of A1 is given by 10 multiplying by 5 minus negative 4 multiplying by negative 4 is equal to 34, plus 2 multiplying by 5 minus 2 multiplying negative 4 all multiplying by 3 is equal to 45. We obtain finally determinant of A1 is 88. We go now to define matrix A2. We obtain matrix A2 by replacing the second vector of A by vector B. We go now to calculate the determinant of A2 is given by 5, and we cancel the first row, first column, and negative 1, and we cancel the first row and the second column. We obtain this. Finally, we have determinant of A2, 2 multiplied by 5 minus 2 multiplying negative 4 multiplying by 5, that's 90. We have negative 3 multiplying by 5 minus 0 multiplying by negative 4, we obtain plus 15. Finally, determinant of A2 is 105. We go now to define matrix A3. We obtain matrix A3 by replacing the third vector of A by vector B. Then we have determinant of A3, 5, and we cancel the first row and the first column. It stay 5 multiplied by determinant of 10, 2, negative 4, 2, minus negative 3. We have 3, and we cancel the first row, second column. We obtain 3 multiplying by determinant of negative 3, 2, negative 3, 2, 0, 2. And the third one, we have 1, and we cancel the first row, third column, and we have determinant of negative 3, negative 4, and 0, 10. Now we have to calculate determinant of A1. We have 10 multiplied by 2 minus negative 4 multiplied by 2 multiplied by 5. We obtain 140 plus negative 3 multiplied by 2 minus 0 multiplying by 2 all multiplying by 3. We obtain negative 18 plus negative 3 multiplied by negative 4 minus 0 multiplying by 10. We have a plus 12. Finally, determinant of A3 is equal to 134. We go now to calculate IA is given by determinant of A1 over determinant of A is equal to 88 over 125 is equal to 704 milliamps. IB is given by determinant of A2 over determinant of A is equal to 105 over 125 is equal to 840 milliamps. And finally, IC is given by determinant of A3 over determinant of A is equal to 134 over 125. We get 1072 amps. After we finish calculation, we go now to SPICE simulator in order to verify our calculation. Let's go together to SPICE simulator. Here is the circuits done by SPICE simulator. We see here V1 is 1 volt, V2 is 2 volt and V3 is 2 volt, and we have our resistor R1 2 ohms, R2 3 ohms, R3 3 ohms, R4 4 ohms, and R5 1 ohm. We go now to analysis, DC analysis, calculate the nodal voltages. We see here that the current through the resistor R1, that's IA, is equal to 704 milliamps. IB is given by 840 milliamps, and finally IC is given by 107 amps. Those values are exactly value we have done by calculation. Thank you for watching this video, and if you have any question, do not hesitate to contact me by email or leave a comment under this video, and I will try to answer you as soon as possible. If you like this video, don't forget to subscribe and share, and see you next time in another